Okay, this is a reshoot of a video that was missing. So you will recall that the last time we have been looking here at player pay, right? And so we've been looking at some examples of average salaries, and we wanted to kind of get a sense of what determined athlete salaries. And you'll recall that when we were looking at this, we said, okay, we can say that athlete salaries are a function of our marginal revenue and our marginal product, right? So we said marginal revenue product, right, which was equal to our marginal revenue times our marginal product is basically how we would determine player pay, okay? And in essence, what we said is that we said that in an era of free agency and competitive markets, players should get pretty close to what they're worth, right? So let's kind of look at a real world example. Let's look at, say, Barry Bonds. Okay, and we know that in 2001, he hit 73 home runs. Okay. We also know that in, say, 1999, 2000, and 2001. So he's played for the San Francisco Giants for all of these years. In 1999, the San Francisco Giants ended second in their division. In 2000, they won their division. In 2001, they came in second in their division. Okay? And then if we look at the attendance levels for the San Francisco Giants in these particular years, we see that in 1999 there was 2,000, excuse me, 365 people. In 2000, we had 3,315,330, right? And then in 2001, we had 3,311,958, right? So if we kind of think about this, during Mr. Bonds' chasing the home run record in 2001, you can almost kind of think of this as that he's drawing in about 1,233,603 fans, right, are being drawn in by his chasing the home run record, right? So, I mean, let's remember what we have here. We've got tickets, we've got concessions, we have parking, right? We have all of these different sources of revenue that comes up to essentially several $1,000,000, right? And if we look at, say, the average ticket price during that time frame, you have an average ticket price in 2001 of $19.24, right? And we have our 1,233,603 fans, and this would lead us to a revenue of about $23.7 million, right, for the San Francisco Giants, right? If we want to look at things like concessions and parking, you're looking at around $163.89 for 2 adults and 2 kids. And if we look at basically our tickets, concessions, and parking for our 1.2 million fans that Mr. Bonds is bringing in, you're looking at about $50.5 million. Right? And remember, he is only earning a salary, right? His salary during this year was $10.3 million. So he's bringing in anywhere from $23 to $50 million. The San Francisco Giants are only paying him $10.3 million. They're definitely getting their money's worth, right? And you can actually see this in the way that it impacted other games. So if we look at additional games here, we can see increases in attendance for these other games. So, for example, the Padres, they had an average attendance of about 22,000 per game. For the series before the Giants came, right? They had a 3-game series with the San Francisco Giants. And during that 3-game series, they were looking at average attendance of about 52,000. 61 per game. All right. So in a way, you can kind of think of this as Mr. Bonds here is increasing the average attendance by basically 30,000 fans. Once again, I mean, these 3 games, if we look at this just for the Padres, is going to increase revenue by $1.24 million to $2.87 million. And remember, this is the Padres. This is not the San Francisco Giants, right? So we can see here that when we're trying to find out and determine how much players are worth, they're actually worth quite a bit of money. And this is what we'll be talking about a whole lot more in the rest of this section in terms of how is it that players are actually not earning, for example, their $50 million or their $23.7 million that they're raising revenue by. They're earning only, say, $10.3 million, right, which is significantly less than what they should be earning. We've got another explanation. This would be the earnings experience profile. And if we look at this in terms of most jobs, we're going to put experience down here. We're going to put earnings up here. And we kind of have something that kind of looks like this, right? So over time, we see as people's experience increases, the amount that they're earning goes up. It kind of actually reaches some maximum here. And then actually experience beyond that actually begins to decline. And we see the exact same thing happening in sports, right? Athletes' initial salaries tend to be pretty low. They gain experience, earnings increase. They kind of have a tendency to top off, and then they even kind of decline as time sets in. And let's look at a couple of different examples here. We have Randy Johnson, who is all done playing, has been done for quite a while, right? So we see here in 1989, he started off with the Washington Nationals at 70,000. Here in 2008, finished off here at about 15.1 million. Of course, Randy Johnson was a pitcher. And do the exact same thing here for, say, Sammy Sosa. So here we see 1990, he starts off with a salary of 100,000, gains a lot of experience, reaches his salary here in 2005 as an outfielder with the Orioles at 17 million. Then the next year falls basically to a designated hitter for the Rangers. And if we want to plot these guys, we can kind of see they have a tendency to kind of follow the exact same pattern that we saw in our, that we see basically with people overall. Same thing here for Sammy Sosa, right, where we kind of have this earnings start off relatively low, begin to increase as experience increases, they kind of reach some maximum, and then of course they begin to decline significantly after that. So what we want to do is we want to kind of try to place a value on athletes, and we can kind of use the tool that we've been using before when we've been looking here at basically, say, marginal revenue. So we've got our teams here. All right. And we have the marginal revenue of, say, our large team. We've got the marginal revenue of our small team. All right. And we see that these guys are going to intersect. And of course, we've been using this to explain winnings, but we can also use it to explain other things. All right, so that you have some P star here, where in essence this P star is kind of basically the price for a unit of talent. And of course, how we define talent can vary from many different ways, right? But in essence, we see here that we have this price for talent. And interestingly enough, I mean, we can use this to kind of explain lots of different relationships. So for example, generally speaking, people have this idea that an increase in salaries leads to an increase in prices for tickets, right? And generally speaking, we have this positive relationship between salaries and ticket prices. So for example, if you look at, say, the Boston Red Sox, and you do a correlation coefficient between ticket prices and salaries, you'll see that you have a correlation coefficient of 0.952. But if you look at the correlation coefficient with, say, the Boston Bruins, which of course is the hockey team, you have a correlation coefficient of negative 0.080, right? So generally speaking, we have this positive relationship between ticket prices and salaries, but of course not always. And like we said, a lot of people have a tendency to think that the relationship runs this way, right? Higher salaries lead to these higher prices for tickets, when actually it's the exact opposite, right? The higher prices for tickets leads basically to these higher salaries, right? And you can see that in terms of our relationship here between these guys, where, remember, let's assume that we have some increase in demand for sports. So for example, maybe people are richer, the population of the city increases, people's preferences for it increases. It can be anything that you want it to be, right? And I mean, this could be for just the large teams, or it could be for the small teams, it could be for anybody, right? It could be both of these teams occurring at the exact same time. The result is going to be the same though, right? So that in essence here, we see the marginal revenue for our large team increasing. And in essence, what this is going to do we see that it increases the price, right, per unit of talent, right? So don't forget, right, our marginal revenue product here for these players, their salaries, their wages are equal to their marginal revenue product, right? But their marginal revenue product is equal to the marginal revenue times their marginal product. Well, here is a reflection of the price that they're getting for each unit of marginal product, right? This guy has essentially gone up. And in essence, we see here that their salaries are increasing, right? So it's not the example that higher salaries are leading to higher ticket prices. It's the exact opposite. Higher prices for tickets is leading to higher salaries. And why are prices for tickets going up? Prices for tickets are going up because demand is increasing. There's more people wanting to watch games. They have an increased preference for games, so they're willing to pay more. There's more people that have moved into the area. Their incomes have gone up. It can be any one of these numbers of things. We also have some supply and demand issues that are occurring here as well, too, in terms of our salaries. And let's look at some examples here. Let's look at one of my favorite examples. This would be baseball players and teachers. All right, so here we're looking at, say, baseball. Here's our teachers. All right, and we have these two different demand and supply curves. So here's our quantity of teachers. Here's our quantity of baseball players, and we have these prices for these players. Okay. And in essence, what we have here, I mean, even if we have identical demand, here's our demand for, say, baseball players. Here's our demand for teachers. Right? We have complete differences in the supply. So here might be our supply of baseball players, right? Whereas here might be our supply of teachers. And we see here that we're going to get completely different points here. Here's our quantity of baseball players. Here's our quantity of teachers. And this is going to lead to some price of our baseball players up here, and we're going to have some price for our teachers here, right? So we can basically explain these differences on good old-fashioned supply and demand. And interestingly enough, of course, if you look at this on, say, a per unit basis, we can actually see that these social values are correct. So let's remember, we have Bonds. He was paid, say, $10.3 million. Right, and let's assume he's drawing in basically 3,311,968 fans, right? If you look at this, this is approximately $3.11 per fan. Right? The fans are only willing to pay $3 to see Mr. Bonds. That's not that much. Our average teacher over here, maybe their salary is, say, $44,000. Okay. They are looking at, say, 30 students, which is, you know, a lot, but still. They're looking at around, say, $1,478 per student. Right? So we see here that the teacher is, in essence, in a way, getting around 475 times more salary in terms of students than Barry Bonds is. Right? So we can explain these changes in salaries in lots of different ways. Let's look at some alternative explanations too, though. One of these is going to be monopsony. And let's remember, with monopoly, you have a single seller, but with monopsony, we have a single buyer. All right, there's no competition for this resource. Right? So usually when people think of the idea of monopsony, they're thinking of some coal mine in some small town. It's the only job in town. But pro sports also fits the bill. Right? I mean, where else are you going to sell your services to? So let's kind of look at what's happening here. Let's look at this in terms of our monopsonist. So we have our quantity of, say, labor. We have our wages. Okay. We have their demand for labor, and there is some supply of labor. Okay. Now, what's really, really interesting is that if we had basically perfect competition, we would have some L star amount of labor, and they would be paid some wage W star. Okay. And this makes sense because, right, some people are willing to work at lower values than others. Okay. And as the price goes up, more and more people come into this market willing to provide their labor services. For the monopsonist, though, they face a marginal expenditure curve that kind of looks like this. Now remember, these people are the sole buyer, right? So under perfect competition, a firm can hire all the labor that it wants to at the perfectly competitive wage rate, W star, right? They can hire L star amount of people at W star. The monopsonist cannot, though, right? So for example, perhaps the first worker is willing to work for, say, $10 an hour, and the second worker is willing to work for, say, $11 an hour, and the third worker is willing to work for, say, $12 an hour. Okay? So if I want to hire the first worker, I need to only pay $10, right? So we have a total wage bill here of, say, $10. If I want to hire the second worker, though, I'm going to have to pay them $11. And that $11, I'm going to have to pay to both the second worker and the first worker, right? So now I'm hiring essentially two workers at $11, so my wage bill goes to $22. If I want to hire three workers, if I want to hire the third guy, he's only willing to come in and work for $12. So we see here that I'm going to pay $12 to basically worker number 2 and worker number 1. Now my wage bill is going up to, say, $36, right? So we see here that the marginal expenditure on how much I'm going to have to pay each of these workers is going up faster, basically, than the wage rate's going up. So what this means is that for our monopsonist, they're going to get to this point right here where they say, look, it's not worth it to hire any more people, right? And we're going to call this guy, say, I'll call it LM for our monopsonist. There's the amount of labor that they're going to want to hire. Okay? Now, interestingly enough, of course, that leads to a marginal expenditure up here, say A, so I'm going to call this guy. Okay? But the price, all right, the dollar value of A, this is the marginal expenditure for another unit of talents, where the marginal revenue product of labor is basically equal to our demand for labor, right? I mean, it's how much it's costing us is equal to this demand, right? This is our marginal revenue product for labor, right? So we see our marginal revenue product of labor is equal to what it's actually costing us, basically the marginal cost at A, right? But interestingly enough, I don't have to pay this wage A, nor do I have to pay a wage of W star to get LM workers. I need only pay a wage of, let's see, I'll call this guy WM. In order to get these people to work for me, right? So like we said, under perfect competition, we're going to see that there would be L star amount of workers hired. They would all receive a wage of W star. But under these conditions of monopsony, we will see something completely different. We will see the firm only hiring LM units of labor, and they will pay a wage of WM. So just like we see this is true for our coal mine, right, in West Virginia, and it's the only job in town, we're going to have to do the exact same thing here in sports because this is a monopsony situation. So we can also see one of the things that explains these guys, right? And this also kind of helps us explain, and we'll talk about this more when we look at unions, why it actually makes sense for athletes to form unions, because the only way around the monopsony situation is to have a union that can negotiate a higher wage, something higher than WM, hopefully closer to A or W star, but that kind of depends upon the strength of the union, and it depends upon the strength of the monopsonist, right, the single buyer, okay? So that brings us into what is essentially the next video, which is our winner's curse. And you'll remember that the winner's curse, we have kind of this idea where we're getting this idea from broadcasting rights where you have inexperienced bidders. This is especially true for the early days of free agency, where kind of owners are unsure how much athletes are actually worth. And so you can have people bidding a lot, but what happens if they get injured? What happens if you have during trades? You have this idea of this winner's curse. It's really, really difficult to know exactly how much this person is worth. And so sometimes, oftentimes, the winner who actually buys the athlete, who hires the athlete, actually loses because the athlete is not worth as much as they thought they would be, right, for a variety of reasons, okay? So that ends our reshoot of this next video, and we're going to do our reshoot of the next video here right now.